Hello, everyone. What we're doing today is working with some survey data from Statistics Canada, learning a little bit of code, and ultimately what we want to do today is recreate this figure that looks a lot like figure 1.3 in the Benjamin and co-authors Labor Market Economics textbook. In our first video, we're just going to be bringing in the data and getting to some basic summary statistics. In a second video, we will create this histogram. So to begin with, we need a couple of things in place. First, you need to go back and make sure you watched our earlier video to get that Canadian income survey. If you remember from there, we went and brought that in and I dumped it here in a teaching demo folder with CIS data here. Ultimately, this is the data set that we want to use. This is CIS data from 2017 that we downloaded via Odyssey, and this is the DTA set. Now, what I've also set up here, just to keep it handy, is a folder where we're going to work out of today. This is where I'm going to be bringing in any of our results and saving them here. Okay, so that's step number one. Step number two, you need to make sure you have Stata. If you are a student at Laurier, you should be able to use the Apps Anywhere via Laurier. I'm not sure how to set that up myself because I have this on my computer. If you want to get it on your own computer, you can go to stata.com and look for the student pricing. It's not a terribly high price here if you want to get the most basic version. And for most of what you're doing in your courses, this most basic version of Stata will work just fine. So once you have Stata, we can open that up and get ourselves started. Now, everyone's Stata is going to look a little bit different. I'm working with version 15. I'm working on a Mac. If you're working on something else, it might look a little bit different, but it's really all exactly the same thing. The first thing we want to do is be able to open that data set that we had downloaded earlier. And when I mentioned earlier that we needed to know the directories, that's going to be coming in handy here. So one thing we can do is work in this command window right at the bottom of the window for Stata. Right above it is our results window. And in that window, we would use the command use, and then we have to tell Stata where to find the data. Now, if you're on a Mac, one of the easiest ways to do that is just to go look at that data set, right-click on it, and you can copy the directory information right there. And so that's what I'm going to do here. Now, if, however, you are on a PC, you're going to have to go into your Windows Explorer, find that directory name that's something like C/myfiles here, whatever it is for you, and then you can hit enter from the command line. Now here we can see that I'm using this data set. It has the full directory name, that Schirle teaching demo folder, and the data set. On the right-hand side, we have a full list of all the variables that are included in this data set, including, fortunately, a brief description of what they are with this label. And down at the bottom right-hand corner of that window, you can find a little bit more information. So for instance, if I were to click on the variable year, you can see down here a little bit about it, what its label is, what type it is, if it's an integer, a byte, a string variable, and how it's formatted. And that can come in handy, as you'll see. Now, generally, however, trying to work out of this command line can be very cumbersome. And if you ever make mistakes and need to back up, you're going to have to redo the entire thing. So one thing we always do is start a do file right away with everything we want to do. And so you click on the do file editor here. That's going to pop up a window for you to work from. And this is where we're going to just write down all of the syntax that we need going forward. Now, instead of trying to copy and paste that directory information every time, one thing I do is start by setting up what's known as a couple of globals. So the global command is how you can tell Stata to say, instead of having to write this long directory name to find this folder every time, just call everything in this quotes EC306. And instead of having to write out this long name for our data set, just call it CIS, okay? And so it's going to be able to call that for us. Then what we can do is type in a much simpler command than what we did before. And here you'll notice I always use quotes because Stata gets very upset with characters sometimes. A $sign gets it to pull in that global name, and I want it to bring in CIS. Now to make sure Stata's gotten rid of anything that it had before, I add in comma clear. Then I can run that just by pressing do from this top right corner of the window. Okay, so now what we see when we go to the results window is it's defined those globals, it's decided to use this data, and again we see it has been loaded with the variables here. Now, it's always worth taking a moment to just take a look at the data browser. This is something you can open to look at the data without worrying about accidentally changing anything. You cannot edit it here. And so when you're looking at these large data sets from Statistics Canada, it's really like a large spreadsheet. You have here the first person who was interviewed in this data set in the year 2017. They're given an ID number. They live in a province, it's coded as 24, that happens to be Quebec. And then it gives you a lot of other information about that individual in all of these variables. You'll notice if you were to go all the way down, that in this data set, we have 92,292 individuals and all of their information. You can get a sense of how that looks. Now you'll notice that some of these are red. Whenever you see that in red by default, that is going to be a string variable. So it's coded as something like a character, like a word. When you see, for instance, numbers, they are in blue. Those are recorded as numbers, and so you're going to be able to use those in formulas and other such things. Figuring out what all of these numbers mean, for instance, what is age group 07, you have to go to the code books to figure that out. Okay, so that came with our download of the data. Now, one of the things that we want to do here today in recreating this particular graph is we need to come up with an average hourly earnings for every individual in this data set. Now, the Canadian Income Survey, when we go to that, is an annual survey, so it looks at what your annual earnings are, and it also asks about how many hours you worked in the year. So let's start by looking for the variables that might be able to help us in getting to what is an average hourly wage out of that information. So we'll start by looking for our earnings variable. And here when we do that, we see there's a whole list of them here, but the main one that we want is the EARNG. So this is going to be your employment income for the year. You'll notice that some of these look very similar. They start with EF. That's for everyone in your economic family. There's also CF, which is your census family. That's more of a nuclear family of parents and their children, their unmarried children to be specific. So it's good to get to know those when you're working with Statistics Canada, but we're going to be making use of the EARNG variable. Now we also need an hours variable. So we will look for hours, or say hour, to keep that simple. And here we have a couple of options. We do not want to deal with average usual hours worked per week at all jobs because we have an annual earnings variable. So we're going to work with this one, which is representing your total hours in the year. Okay. Now what we can do with that then is create a variable for what your hourly wages are in the year itself. And we're going to add that to our do file here. Okay, so I'm going to call this AVG wage. You can call it anything you want to. And that's going to be your total earnings for the year divided by the total hours. That effectively gives you an hourly wage on average that you had during the year. Now when I run that, and here I'm just going to highlight it and hit do to get that one piece going, I'm going to get an average hourly wage variable. And one of the things that we usually want to do first off is just run a quick summary of that to see what it looks like and look for anything odd. So for instance, here when we're looking at the results window and we have an average wage information, detail gets me the percentiles and a bit more information about the distribution. We see first that some of these smallest numbers are actually negative. Now, what does it mean to have a negative hourly wage? It's as though you're actually paying somebody else to let you work. That obviously isn't going to happen very often in our labor market. Instead, what this is generally representing are individuals who are self-employed. And so when they report their annual earnings, that can actually be negative depending on their revenues and expenditures for the year. You'll notice that we have some percentiles. The median is just over $23 per hour. The mean is 32. Now, I'm going to point out, however, this isn't an average representing our population at this time. We also have, of course, somebody who's earning over $28,000 per hour in this data set, and that seems a little bit odd to me. So I think it's always useful to go back and take a closer look at some of the variables that are going into here. So I'm going to first drop that little bit here and say, well, what does that hourly or that hours variable actually look like? And we'll look at that detail. Now here we see that when it comes to those annual hours, there's some people here in that average wage calculation that are only working 1 hour in the year. There's some other individuals who are working 8,736. And if you work that out with 52 weeks in the year and 7 days in a week, they're working 24 hours a day apparently, which we know is just physically impossible for any real human being. And so when we start looking at these types of things, we think, well, we're going to have to make some judgment calls about who to include and who not to include in our data set when we're trying to represent a population of what a typical worker might look like. Now, how to make those judgment calls isn't always obvious. It usually takes some experience and a really clear sense of who you're trying to work with. But I'm going to start off with a couple of things, and I'll just say these judgment calls mostly come with experience more than anything else. The first thing I'm going to do is just drop anyone who had earnings that were less than or equal to 0. So that's going to get rid of some of those self-employment earnings. It's also going to get rid of anyone who didn't earn anything at all during the year, right? They're not considered workers. They just happen to be in our data set. I'm also going to get rid of anyone whose hours of work were missing, and that's going to be coded as .A in this data set. That's a common thing in Statistics Canada data. Now, what I also want to do is just very directly get rid of those individuals who were self-employed. And so here I have a flag for self-employment. We'll just take a moment to look for that to see how I got it. I just looked for self. What do we know about self-employed? Well, here we have a flag. It's a dummy variable for whether or not somebody was self-employed during the year. We also have an earnings variable for any self-employment income that is a combination of both farm and non-farm income. And so those are the pieces of information that I'm going to use to drop anyone who seems to be self-employed. Now, as a third thing, one thing I wanted to do was just get at sort of a core group of workers. And when I did that, let's do this first, I started by just saying, well, let's just take the people between the ages of 20 and 64. And when we look back at those codes for what those were, I put in the number 6 and 14 representing that age group. Now, when I ran that, however, I get this error code that says type mismatch. And that makes me go back and say, oh yeah, that was coded as a string variable. Now, you could go in and just put quotes around all of the numbers to capture that, or what you can do is use the command dstring. When you know it's all coded as numbers, you can say dstring this variable for me, turn it back into numbers. Replace is telling Stata not to create a new variable, just replace the numbers in the one that I have right now. And once you do that, you'll be able to use a much simpler code here. So that always comes in handy. Now that we have all of this information where we've said, you know what, we're going to use only these individuals. We want the individuals 20 to 64. This is how I'm going to create my average wage variable for them. Then what we want to do is, again, take a closer look at their average wages, see what the average looks like, what the median and some of the distribution numbers look like. So we're going to go back to that summarize command. But one thing we need if we're going to represent the Canadian population is to use the survey weights. Now, in most Statistics Canada surveys, there's going to be weights attached to each individual that represents how many people they represent in the population. A good thing to know is that this is not a randomly sampled, not a random sample from the population. Rather, what we do is we tend to oversample in some geographic regions, undersample in others, so that we have full representation. So for instance, if we only did a random sample, we'd never get anyone from Prince Edward Island. We'd have a ton of people from Toronto, but we want to know about Prince Edward Island. So we have to use these weights to get weighted averages that represent the population better. So now what I'm going to do is just rerun this entire file. Keep in mind, the nice thing here about a do file is I can just start from scratch again anytime and quickly rerun the whole thing. Now when we look at our results window here, we have an average wage for our population in Canada, aged 20 to 64, of just over $33 per hour. The median, or 50th percentile, is $24.62 when you round that up. And we can also find here a 10th percentile and 90th percentile, which helps us understand a bit more about how wide that distribution of hourly wages is in Canada. Now, we don't want to have to rerun this every time we need to find this information. So one thing that we always do is include a log. What a log does, or a log command does, is it tells Stata to write all of the information that's showing up in this results window and save it to a file for us. So what I do here is near the top, I'm going to say log using, and I'm going to tell Stata where to store that information. It's going to create a text file for me, okay, that I called Stata CIS demo. It's going to put it in that EC306 folder that I specified earlier. And the extra stuff here is to say replace this every time I run the do file, and the T here is to tell it to make it a text file as opposed to other formats that are available. Now at the bottom of the file, I need to make sure that I close it up so that it stops the program from saving it to this file, and then it'll save it and tuck it away into that EC306 folder that we want. Now just as a handy tip to save yourself from swearing at your computer many, many times, I also tend to write capture log close here at the very top of the file. That way if your program ever gets interrupted and you need to restart, you're not going to get an error message. So from there, I'm just going to rerun this file quickly. What we have now is our file fully run from beginning to end. You can see here it started the log where we put that, and it started this file here. It didn't have one before. It started it there and opened it, and then down at the bottom it closed it and saved it for us. So now when we go over to this folder here where we had the EC306 information being stored, we have our CIS demo.txt, and that will have all of that information stored. Now, of course, before we go, we need to save our do file. When you save it, you'll be able to reopen it in any kind of text editor and be able to work with it again and hopefully pass it on to other people as well. If you don't specify what the ending of that should be, it will be by default .do. So I'm going to save that there, and that goes into my folder as well. Now, before we go, I'm going to mention two things. First, we're going to come back in a separate video to build that histogram. We're going to reopen this again. But when we are finished, we close up everything and we close up Stata. Now, one thing to know is when you go to quit Stata, a window will always pop up here that tells you your data and memory have changed. Do you want to save the changes before quitting? And a lot of people by default will say, yes, save it. I want to make sure I don't lose anything. You need to remember to click don't save, because what this is going to do is take that original data set that you started with, that you downloaded from the library, and it's going to write it over. So it's going to take all of those changes, every one you dropped, they're going to disappear. If you ever have to start over again, you're going to have to go back to the library and get that data set again. So don't save it. Make sure you just close it up there, and then you are done. See you in the next video to get back to creating this histogram.